Hello students, good afternoon. In the last class, we study about some different image formation due to the convex lens. Means when the position of the object is changes, the image formation is also changes. When the object is at infinity, the point image is formed. Or when the object is on 2f, the image is as it is. Or when the object is at f, the image is enlarged and which is found out at infinity distance. And when the object is in between the focal length and the center of curvature, the image is virtual and the virtual image is enlarged, erect, and we have got the virtual image. Then here the image formation due to the concave lens. Image formation due to the concave lens. We know that concave lens always gives the virtual image. Concave lens gives the always virtual image. Convex lens gives the real as well as the virtual image. But concave lens gives the always virtual image. So in the last class we study about the virtual image. Virtual image is that image which is found out due to the diverging rays. A image which is found out due to the diverging rays is known as a virtual image. Otherwise, in the simple form, for the refraction, where the object is situated, that side the image is formed, that image is known as a virtual image. Let's see how to draw the ray diagram for the concave lens. So here this is a biconcave lens. If the object is situated, if the extended object is situated on the principal axis, this is known as an extended object, then draw a ray diagram. So here, if the first ray of light is incident on the concave lens, which is propagated straight, and when the ray of light is incident on the lens, due to the concave lens, it is a refracted. But the lens is a concave, so this is a divergence from the principal axis. So it is a divergence. Divergence means the ray of light is a move away from the principal axis. Then again the ray of light is a reflected back in the same direction in the straight line and which is a meet at the principal focus. Draw another one ray of light which is an incident on the optic center and this again reflected back. Then draw a arrow mark where both the incident ray and the refracted rays are meet. So here this is the object AB and this is the image which is a find out. Suppose this is the A dash B dash. This here this A dash B dash, the height of a dash B dash as compared to AB is a very small. The height of a dash B dash as compared to AB is very small. Means this image is known as a diminished image. This image is known as a diminished. If the height of image is a small as compared to the height of an object is known as a diminished. If the height of the object and as compared to height of an object and image, if the height of image is enlarged, then that image is known as an enlarged image. But here, this AB height of an object and this A dash B dash is a height of an image. When we compare both the rays, that time we got their height of an image is a very small as compared to the height of an object. So we write here, due to the concave mirror, due to the concave mirror, lens, we got diminished image. Then here, due to the convex lens, we got when that image is a real, that image is a inverted. But here, due to the concave lens, the image is a erect. We know that erect means as it is. That the height of an object in an upward direction, then upward direction. So the image due to the concave lens is erect. Second point, due to the concave lens, the image is erect. So this is the second point. This here, third point. The image which is a find out due to the diverging rays. The image which is find out due to the diverging rays. Means when the image is find out due to the diverging rays, that image is known as a virtual image. Otherwise, where the object is situated, same side the image is also there, means that image is known as a virtual image. So due to the concave lens, we got always virtual image. So here the third point, the image is a virtual. The image is a virtual. Image is a virtual. Then the question is arises that what is the difference in between the virtual image due to the convex lens and the virtual image due to the concave lens? Then here the difference is that the image due to the convex lens is always magnified. When the convex lens gives the virtual image, and when we got the virtual image due to the convex lens, when the object is situated in between the optic center and the principal focus, that time we have got the virtual image due to the convex lens. But the image is enlarged as compared to the height of an object. Means as compared to height of the object and height of the image, the height of the image is large in the convex lens. But in the concave lens, the height of the image is less as compared to the height of the object. So the image is a virtual. So here remember that the image which is find out due to the concave lens is a virtual as well as a diminished. So here. So in this type, this is a ray diagram which is related for the concave lens. Where if we change the position of the object, the image is always diminished and virtual due to the concave lens. But when the image which is find out due to convex lens, when the position of an object is changes, the image formation is also changes. So in this type, this is a difference in between the image formation due to the concave lens as well as the convex lens. Then the next part of this chapter is lens maker formula. Lens maker's formula. In the last class, we derived an expression that gives the relation between N, U, V and R. So in this part, we study about the lens maker formula. The relation is used by using the convex spherical surface. Then that derivation is used here. So here in this chapter, this derivation is a very important and which is repeated in your annual examination for 5 marks. So this is to derive the lens maker's formula. So to derive the lens maker's formula, we use the convex lens. We use the convex lens, means by using convex lens. By using convex lens, we derive the relation between, or we derive the expression for the focal length as well as the radius of curvature and the refractive index by using the relation between N, U, V and R. So here, to derive this lens maker's formula, we consider a lens. If we take a lens, consider a lens. So this is a convex lens, optic center. Draw a principal axis, a line which is passing from the optic center is known as a principal axis, and where the object is situated and the image is also formed on the principal axis. So here, to derive this expression, consider a point object. Consider a point object which is situated on the principal axis. Suppose a point object O is situated, which is a luminous object. When the point object O is situated on the principal axis, suppose this is a luminous object, there are number of light rays are propagated from this object. Number of light rays are propagated from this object. Suppose the first light ray is propagated undeviated. Suppose the first light ray is propagated from the optic center undeviated. Consider another one ray of light. Consider another one ray of light which is an incident on the convex lens from the object O. Suppose another one ray of light which is an incident of the convex lens, and when the ray of light is an incident of the convex lens, it is a refracted. And when this ray of light is a refracted in the glass medium, and again the refracted ray of light is propagated from the denser medium to the rarer medium. Starting, the ray of light is propagated from rarer medium to the denser, and again the ray of light is refracted in the lens, and again the ray of light is refracted, and the image is formed on the principal axis. Suppose this is the image find out on the principal axis. So this is known as the object distance. The distance in between the center of the lens and where the object is situated. The distance in between the center of the lens and the object space, the distance is known as the object distance, and that is denoted by the letter U. The distance in between the center of the lens and the image, that distance is known as the image distance V. So here, the point object is there, so the image is also point. Means the image is a real. The image is find out due to the refracting rays. So the image is a real. But here, the image formation is the image formed due to the convex lens is by using the two stages. The image formed in the convex lens is according to the two stages, or by using the two surfaces. Means the first surface refraction is takes place, and again there is a second surface refraction is takes place, and finally we have got the image. Means in this lens there are two refractions that takes place, and we have got the final refraction and final image at the point I. But first we study about how the refraction is takes place due to the two spherical surfaces and how the image is formed. Then first we study about this is a final refraction due to the two surfaces. Means where the object is situated, point object is situated on the principal axis, and we have got the point image on the principal axis. But the image formation is takes place in two stages. So by using the convex lens and by using the concave lens, when there is a separate refraction is takes place, then derive the expression by using the two stages. So listen carefully. This is a very important derivation. Then first we study about the refraction through the first surface. Means if we take, there are two surfaces are there. Suppose these two surfaces are A, B, and suppose this is a C, and suppose this is a A, D, and C. So there are two refractions that takes place, and the final image is got. Then first study about the refraction through the surface A, B, C. First we study about refraction through the core surface A, B, C. Means in this we first consider the first spherical surface A, B, C. This here, if we take the first spherical surface, consider the first spherical surface A, B, and C. Draw a principal axis. So here, this spherical surface means we consider the first part of this spherical surface A, B, C. because this is a biconvex spherical surface. So if we consider first spherical surface ABC, then here how the refraction is expressed due to the first spherical surface ABC. Then here there is a point object is there. Suppose from the point object, the first ray of light is propagated in the straight line direction without undeviated. If we consider the second ray of light, which is an incident on this spherical surface. Suppose this is a OP with the ray of light is a incident ray. When this ray of light is an incident on this spherical surface, it is a refracted. Means this is a convex spherical surface. And this in this convex spherical surface, this convex spherical surface is a placed in a air medium, or this is a placed in a medium whose refractive index is a N1. Suppose the refractive index for this convex spherical surface is a N2. N1 is a less than N2. N1 is less than N2. Means N1 is a rarer medium. N2 is a denser medium. Where is the object situated? The object is situated in the rarer medium. So here the ray of light is propagated from the rarer medium and which is the incident on the denser medium. When the ray of light is propagated from rarer to denser, it bends towards the normal. Means it bends. So here this is a refracted ray. Draw a normal ray. Draw a normal ray at the point of incidence. Draw a normal ray at the point of incidence. Suppose this is a OP incident. This is a P. Q is a refracted. Then here, this normal ray is at the center of curvature for the first surface. We know that in the convex spherical surface, there are two center of curvatures and there are two radius of curvature. So here, when the ray of light is an incident on this, it is a refracted and we have got the image at the point Q. But this is not a final image. This image is a find out due to the only one spherical surface. So this image, if we consider this point is a I1. I be the final image. But this is the image which is a find out due to the first spherical surface. So this is not a final image. So this image is found due to the first spherical surface. So here this is the I1. And draw a normal line which is a passes or which is at a passes from the center of curvature. Means this distance is known as the radius of curvature, that is known as a R. So there are two spherical surface. There are two spherical surface means there are two principal focus as well as there are two radius of curvature. So here if we consider this center of curvature means this distance is the radius of curvature for the first part. So in this type we have got the image at I1, but this image is not a final image. So consider here this distance is considered to be V1. This is the image distance, but this is not a final image. This image is found due to the first spherical surface. So we consider here I1 and V1 with the image distance. But the object is the same. So consider the object distance U. So in this type we label the diagram and give the arrow marks. This arrow mark shows the incident ray and this arrow mark shows the refracted ray. Means where the ray of light is an incident and where the ray of light is a refracted. So this is the image formation due to the first spherical surface. This here we write a formula. In the last class we derived expression which gives the relation between N, U, V and R. So in the last class we derived that formula, that is a minus N1 divided by U plus N2 divided by V is equal to N2 minus N1 divided by R. So we using the relation between N, U, R. We use this formula. We use the last class formula or we use the relation between N, U, V, R and we apply the values for this equation. So here, when we apply this formula for this figure, here N1, where the object is situated. N1, refractive index for where the object is situated. What is the meaning of U here? Object distance. V means image distance. R means radius of curvature. N2 means the refractive index for the denser medium. N1 means the refractive index for the rarer medium. So here, when we apply this formula for this figure, then when we compare this formula and this figure, that time we observe that N1, where the object is situated in the N1 medium. So right here, N1 divided by object distance is U. Object distance is U. This here minus sign indicates that according to the Cartesian sign, the incident ray is in this direction and we measure the object distance in the opposite direction because all the distance are measured from pole of the curvature. So this is the opposite and this is the incident ray. Both are in the opposite direction. Object distance is the opposite direction according to the incident ray. So we consider here minus. So minus N1 divided by U. Then here next part is the image is found in the denser medium. See here, the image is found in the denser medium whose refractive index is a N2. So here plus N2 divided by V. N2 denser medium, V image distance. What is the image distance in figure? V1. So we write here V1. Image is I1 and the distance is V1. So when we compare both the equations, the image distance is V1. So replace this value V1. Here, in formula, the image distance is plus. Then see here, image distance is in this direction. And the incident ray is also in the same direction. So the image distance is a positive. So it is a plus N2 by V1 is equal to N2 minus N1. N2 minus N1 divided by R. So here, in the biconvex lens, there are two radius of curvature. For the first spherical surface, we consider R1, and for the second spherical surface, we consider R2. So here, this is a N2 minus N1 divided by R1. Because we apply the formula for the first spherical surface, this here, R1 is a plus or minus. Then, for a convex lens, radius of curvature is positive. Because the incident ray is in the same direction and we measure the center of curvature or we measure the radius of curvature in both are in the same direction. Means by applying the Cartesian sign convention, both are in the same direction. So we apply here plus R1. So in this type, we use the relation between NU VR for the first spherical surface. So this is the equation number 1. Equation number 1. That is a minus N1 by U plus N2 by V1 is equal to N2 minus N1 divided by R1. So this is the refraction due to the first spherical surface. Then here, refraction through the second spherical surface. Second part, refraction through A, B, C. Refraction through the second spherical surface, that is the ADC. So here compare the ADC. So take the second surface ADC. So consider the second spherical surface ADC. ADC. Draw a principal axis. So here, how the image is formed in the second spherical surface. How the image is formed in the second third surface, that is the ADC. So here, in this ADC, so see the figure, in the second part ADC, consider this part only. So when this is a second part, object is not there. When we consider the ADC, the object is not there. Means the real object is not there. This real object is a work for the first spherical surface only. The real object is a work for the first spherical surface only. But in the second part, the image which is a find out due to the first spherical surface is a work as a virtual image for the second spherical surface. Means for the second spherical surface, the object is not there, but the image which is formed due to the first spherical surface is a work as a object for the second spherical surface. Then here, in the due to the first spherical surface, we have got the image here. Okay, already there is an image is formed at the distance v1. So draw here that I1 be the image, I1 be the image which is a find out, the image which is a find out due to the first spherical surface is already here. So this is the image. So in the second case, the real object is not work, but the image which is a find out due to the first spherical surface is a work as a object for the second spherical surface. Here, the image due to the first spherical surface is a work as a object for the second spherical surface. Means this is an object, but this object is not real. This object is not real because this is the image for the first spherical surface, but this work as an object for the second spherical surface. So we consider here this image is a virtual image. So here this image is not real. This image is a real. Sorry, this image is not real, but this image is a virtual. So here this is a draw a ray diagram. In this, the ray diagram. It is a bend, it is a diverge, and we have got the final image at a distance r. So this is the final image, which is a find out at a distance v. This distance is a v1. So here, this I1 is an image due to the first spherical surface. But for the second spherical surface, this I1 image is a worked as an object. But this object is not real. So this image is considered as this image which is a worked as an object. So the object is a virtual for the second surface. Then due to the divergent rates, we have got the image, and that image is at a distance I, or that image is I, and that image is a real. So in the second case, object is a virtual, but the image is a real. In the second case, the object is a virtual, but the image is a real. What is the object distance here? Object distance is a v1. What is the image distance here? V. So in this type, by using the two spherical case surface, we have got the final image, and that image is a I. So this final image is formed in this way. First, there is an image formation due to the first spherical surface, and there is an image formation due to the second spherical surface, and we have got the image I at the finally. So here, this is a refractive index is a n2, and here we have got the image is a n1. So substitute the values. Substitute the values in the equation number, or in the relation n u v r. So again consider this formula, minus n1 divided by u plus n2 divided by t is equal to n2 minus n1 divided by r. So this is a constant formula we derived in the last class. Then again substitute the values in this equation, or these values are related to this figure. So here, what is the object distance here? Object distance is a v1, because this is a image due to the first surface is a work as an object for the second surface. So here, what is the object distance here? Object distance is v1. Object distance is a v1. Where is the image formed is there? Where is the refraction takes place? The refraction is takes place in the denser medium. So we take here N2. And this object is not real. This object is a virtual. So consider minus. So here object is we compare both the equations N1 by U. N1 means refractive index for the medium where the object is situated. Here object is worked or the refraction is takes place in the denser medium. So refractive index for the object distance is considered to be N2 and the object distance is V1. But the object is not real. This object is a virtual. So we consider here minus sign. Then next image. Where is the image formed? V. That is a plus. Image formed or image is takes place in the medium N1. Therefore N1 divided by image distance is final image is find out at a distance V is equal to N2 minus N1 divided by R. But here for the second spherical surface, the center of curvature is this side. Center of curvature C2 for this side and the distance in between both of them is known as the radius of curvature and this is considered to be R2. So here the incident ray is in this direction and the radius of curvature is in the opposite direction. So we consider here minus R2. So this is the equation number 1 and this is the equation number 2. Equation number 1 and equation number 2. Then add both the equations. When we add both the equation, we got the new equation. So by adding equation 1 and 2, by adding equation 1 and 2, equation 1 and 2. When we add both the equations, minus N1 divided by U plus N2 divided by V1 minus N2 divided by V1 plus N1 divided by V is equal to N2 minus N1 take common in bracket 1 divided by R1 minus 1 divided by R2. So when we add both the equations, we have got the new equation. Then cancel the similar values. N2 by V1 plus N2 by V1 minus N2 by V1 and we got the new equation that is a minus N1 divided by U plus N1 divided by V is equal to N2 minus N1 into 1 divided by R1 minus 1 divided by R2. So in this time we have got the new equation. So take outside N1. When we take outside N1, so when we take outside N1 in bracket 1 by U, otherwise 1 by V minus 1 by U is equal to 1 by V minus 1 by U is equal to N2 minus N1 in bracket 1 by R1 minus 1 by R2. So we know that 1 by V minus 1 by U, this is known as a Lenz equation or this is known as a Lenz formula and 1 by V minus 1 by U is equal to 1 by F. So substitute this value N1 1 divided by F is equal to N2 by N1 minus N1 by N1 in bracket 1 by R1 minus 1 divided by R2. So this N1 is equal to 1. And if this is an air medium, means N1 is equal to 1. If this is a denser medium, then we compare this N. N1 is equal to 1 or N1 is a rarer medium. That time N1 is an air medium and we know that the air medium refractive index is a 1. Therefore, 1 by F is equal to in bracket N by 1, that is a N, N1 by N1 minus 1 in bracket 1 by R1 minus 1 by R2. So this formula is known as the Lenz-Makers formula. So this is a very, very important derivation. So see here, in this type, we derive the expression for the lens maker's formula. For the lens maker's formula, we first take the lens, convex lens. A point object is situated on the principal axis. From the point object, number of light rays are propagated. Suppose the first light ray is propagated in the straight line direction. Another one ray of light is incident on the lens. It is refracted and the image is found on the other side of the principal axis, and that image is I. So this image is real and the distance is V and the object distance is U. But this image is formed due to the two spherical surface. So in this derivation, we derive the expression, that is a relation, or we derive the final image formation, how the image is formed due to the two spherical surface. First we consider the first spherical surface ABC. First we consider the first spherical surface ABC, where the point object is situated. Then the ray of light is incident on this spherical surface. This surface is known as a convex spherical surface. So the ray of light when incident on this, the rays are refracted and the image is formed. But this image is not a final image. This image is formed due to the first spherical surface. So here, this image is a real. Here the object is also real. So here, we draw a normal line, and that is known as a center of curvature for the first spherical surface. And this distance is known as the radius of curvature for the first spherical surface. So we consider here R1. So this is not a final image. So we consider here I1, and that image distance is considered to be V1. The spherical surface is a denser. So that is a refractive index is a N2, where the refractive index is a N1. So this is object distance U. Then we use the first this formula, that is a relation between N U V R, which is derived in the last class. So we take that formula. What is this formula? Minus N1 divided by U. Minus N1 by U plus N2 by P is equal to N2 minus N1 divided by R. So when we apply this formula to this figure, compare the formula and figure. N1, that is a refractive index where the object is situated. So object is situated in N1 medium, that is a N1, object distance is a U, plus object distance is U, but incident ray in this direction and we measure in the opposite direction. So we consider here minus U, that is a minus N1 by U, plus N2, where the image is found, that image is in the both the directions are same. So we consider here V1. So this is a plus, is equal to N2 minus N1 same divided by this is the radius of curvature for the first spherical surface. Both are in the same direction. According to the Cartesian sign convention, this is a plus R1. So this is the equation number 1. Then consider the refraction through the second spherical surface ABC. According to this, the image formed due to the first spherical surface is a work as an object. So this is a work as an object. So this object is not a real. This is an image due to the first spherical surface. So this object is known as a virtual object. Then this is a object distance. This is a final image. Then we apply the same formula here. Minus N1 by U plus N2 by V is equal to N2 minus N1 divided by R. So when we compare this formula to this figure, minus N2, because the refraction is takes place in the denser medium. So N2 divided by P1. Minus, because this is not a real object, this is a virtual object, so we consider here minus. Plus N2 N1, but the final image is found in the rarer medium. So we consider here N1, and the image is found at the distance V. Both are in the same direction, so we consider here plus is equal to N2 minus N1 divided by minus R2. That is a minus because the radius of curvature for the second spherical surface is in the opposite direction, so we consider here minus R2. Or radius of curvature for the concave spherical surface is a minus. So here, this is the equation number 2. Then add both the equations. When we add both the equation, the new equation is formed. That is a minus N1 by U plus N2 by V1 minus N2 by V1 plus n1 by v is equal to n2 minus n1 in bracket 1 by r1 minus 1 by r2. Therefore, plus n2 by v1 minus n2 by v1 get cancelled, and we got there minus n1 by u plus n1 by v is equal to n2 minus n1 in bracket 1 by r1 minus 1 by r2. So here, if we take n1 common, here 1 by v minus 1 by u is equal to n2 minus n1 in bracket 1 by r1 minus 1 by r2 is equal to 1 by f. Here, according to the Lenz's formula, 1 by p minus 1 by u is equal to 1 by f is equal to n2 by n1 minus n1 by n1 is equal to 1 by r1 minus 1 by r2. So, n1 by n1 is equal to 1. If n1 is a radar medium, if the value of n1 is a 1, then we substitute here 1 and we take n2 is equal to n. We consider here n2 is equal to n and n1 is equal to 1. Then 1 by f is equal to n minus 1 in bracket 1 by r1 minus 1 by r2. So this formula is known as the Lenz-Maker's formula. So in this type we derive this expression, that the expression is depends upon the relation between n, u, v and r. So in this type we derive this expression. So this is a very important derivation which is related for the annual examination, or this formula is used for the numericals or any other numericals. This is depends upon the Cartesian sign convention. So here how to apply the plus sign or minus sign according to the Cartesian sign convention, or where the image is a real or where the image is a virtual. Next part of this chapter, the power of a lens. Power of a lens. Power of a lens is the ability of the lens. Power of a lens is the ability of the lens to converge or diverge when the ray of light is incident on it. So power of a lens is defined as it is the ability of that lens to converge or diverge the ray of light incident on it. So power of a lens is defined as it is the ability of the lens. It is the ability of the lens. It is the ability of the lens to converge or diverge. To diverge when a ray of light when a ray of light is incident on it. And power of a lens is a reciprocal of a focal length. Power of a lens is reciprocal of a focal length. The unit for the focal length is a meter. So the unit for the power is, the SI unit of power is dioptry. The unit for one last question, that is what is the unit for power? SI unit for power. The SI unit for power is a dioptry. So otherwise, It is also defined as it is even a ray of light parallel to the principal axis at a unit length, or when the ray of light a tangent, or when a ray of light which is a incident parallel to the principal axis at a unit length, when we take the tangent of that length is also known as the power of a length for a unit length, and the power of a length is a reciprocal of a focal length, means P is equal to 1 by f. P is equal to 1 by f. The SI unit for the focal length is a meter, but the SI unit for the power is known as a dioptry. So this is a SI unit. So in this step, if we draw the related formula for the power of a lens, consider a convex lens, draw a principal axis, when a parallel ray of light is incident on the lens, which is a converges. So this distance is known as when the ray of light is refracted and which is a converges at the principal focus here. Suppose this is a O, A, F. This is the angle theta. So the tangent of the angle is also known as a power of a lens for a unit length. Then here tan theta is equal to AO divided by OF. So tan theta is AO divided by OF. The tangent which is drawn parallel to the principal axis at a unit length is known as the power of a lens. So here tangent which is drawn at a unit length. Unit length means unit length. Unit length. A ray which is parallel to the principal axis at a unit length means OA is equal to 1. So when AO is equal to 1, OF is equal to, so tan theta is equal to, AO is considered to be 1 and OF is known as the optic center to the principal focus, that is known as a focal length, 1 divided by F. So when the ray of light parallel to the principal axis which is at a unit distance, that is known as the power of a lens. So here this tangent which is drawn, the tangent which is drawn at a parallel to the principal axis at a unit length is known as the power of a lens. So this tangent is known as the power of a lens, and power of lens by according to this figure we have got 1 by f. So in this type power of a lens is a reciprocal of a focal length, and therefore the unit, otherwise f is equal to 1 by p. If the value for the f is given, then we can find out the power directly. But that is a power is a reciprocal of a focal length. So in this type, we prove this equation by using this figure. So we draw a tangent which is parallel to the principal axis at a unit length. That is known as the power of a lens. So in this type, tan theta is equal to AO divided by OF. Tangent, that is AO is equal to unit length. So AO is equal to 1 meter. Therefore, AO is equal to 1, that is the F is equal to 1. Therefore, power is equal to 1 divided by F. Then power is defined in the form of a dioptry, or the SI unit for the power is a dioptry. So in this step, we derive the expression for a power of a lens. Means that lens or the ability of the lens to converge or diverge. If the lens is a concave, means when the ray of light is an incident on it, it is a diverges and again meet at a point on the principal focus on the other side. So that ability of a lens is known as the power of a lens. The next part of the chapter is a lens formula. That is a lens formula is we derive the expression for 1 by f is equal to 1 by u minus 1 by p. So when we derive this expression, that expression is known as a lens formula. So we derive this expression by using a convex lens. So draw a ray diagram for the convex lens. To derive this expression is also related for the fibers. Then, by using a convex lens, when we derive this expression by using the convex lens. So consider a convex lens. The refractive index of a convex lens is a n2 and which is placed in an air medium. Draw a straight line which is passing from the optic center. Consider a extended object. AB with the extended object which is situated on the principal axis. First ray of light is incident on this, which is refracted from the principal focus. Another one ray of light is passes from the optic center. Both the rays are meet and there is a formation of an image. Draw a perpendicular MN or MO. So this AM with the incident ray. Suppose this is the object AB, then consider this is the A dash B dash. Due to the convex lens, we have got the inverted image. When the position of the object changes, the size of the image is also changes. Due to the convex lens, we have got the real image, inverted image. Then, to derive the expression for the lens formula, we use the convex lens. This distance is known as the object distance. This is the principal focus. So this distance is known as the focal length. And this distance is known as the image distance. So to derive this expression, compare the two triangles. Compare the two triangles or compare the two similar triangles. So here this ABO is a right angle triangle. At the same time B dash A dash O be also the right angle triangle. MOF and A dash B dash A dash F. So in this type there are four triangles are there. Compare the similar triangles. When we compare similar triangles, that is A, B, O and A dash, B dash, O. When we compare the two similar triangles, compare the similar sides. When we compare the similar side, that is AB divided by A dash B dash. A dash B dash is equal to AB divided by A dash B dash is equal to OA divided by OA dash. OA divided by OA dash. Suppose this is the equation number 1. AB divided by A dash B dash is equal to OA divided by OA dash. Then again compare the another two similar triangles, that is MOF and FA dash B dash. FA dash B dash. So again when we compare the two triangles, MO, compare the similar sides. MO divided by FO is equal to MO divided by FO. And the other one is, when we compare the similar sides, that is a MO divided by A dash B dash. MO divided by A dash B dash, and the other one is a OF divided by FA dash. OF divided by FA dash. Equation number 2. First compare the two triangles, similar sides. Again compare the two triangles with the similar sides. This here, this MO and AB, both are similar and parallel. Therefore, MO is equal to AB. Therefore, MO by AB dash is equal to AB divided by A dash B dash. AB divided by A dash B dash. AB divided by A dash B dash is equal to OF divided by FA dash. So equation number 2 and equation number 3. Then compare the equation 2 and 3. When we compare equation 2 and 3, compare equation 2 and 3. When we compare equation 2 and 3, one side is a similar, so the other side is also same. One side is same means the other side is also same. Therefore, MO divided by A dash B dash is equal to OF divided by FA dash. Then we compare the equation. One side is same means the other side is also same. That is a OA by OA dash. OA divided by OA dash is equal to OF divided by FA dash. OF divided by FA dash. This here, substitute the values of all these. OA, so see the figure. OA is known as a object distance. Incident ray is in this direction. We measure the distance in a opposite direction. Means OA is considered to be minus U divided by OA dash. OA dash is known as a image distance. Both the directions are same. So we consider here plus is equal to OF. OF is a focal length. Both are in the same direction. Means this is a plus. Yeah. Divided by FA dash. FA dash, the value is not given. So we consider here OA dash minus OF. OA dash minus OF. OA dash minus OF. Then substitute the values. Minus U divided by V is equal to F divided by OA dash. OA dash is a V plus V minus OF. Both are in the same direction. That is a minus here. Then cross multiply that equation. When we cross multiply this minus, when we cross multiply minus U into phi minus F is equal to phi F. So minus UV minus plus UF is equal to PF. So divide all of these by UVF. Divided by UVF. So when we divide all these by UVF, so UV get cancelled and we got here minus 1 divided by F. Here UVF. So UF cancel plus 1 divided by P is equal to divided by UVF. VF get cancel 1 by U. So arrange this equation. When 1 by P minus 1 by U. So 1 divided by P minus 1 divided by U minus when this goes to this side is equal to 1 divided by F. So this formula is known as the length formula. So remember here 1 by V minus 1 by U is equal to 1 by F. The relation between U, V and F is known as the length formula. That is a 1 by V, image distance is a positive, object distance is a in opposite direction it is a negative, and F is the focal length which is also positive. So in this type we derive this expression. To derive this expression, we draw the ray diagram for the extended object, and when we compare the two triangles, first one is a ABO and OA dash B dash. When we compare the two triangles, we compare the two sides. That is the AB divided by A dash B dash is equal to OA divided by OA dash for the first similar triangle. Then we consider the second similar triangles MOF, FA dash B dash. And in this we again compare the similar sides MO divided by A dash B dash is equal to OF divided by FA dash. So MO is parallel to AB. Both are same. So we replace this value. AB divided by A dash B dash is equal to OF divided by FA dash. So one side is when we compare the equation 1 and 3, one side is the same, so other side is also same. Therefore, OA by OA dash is equal to OF by FA dash. OA is the object distance, opposite side minus U divided by B. OF is a F, OA dash minus OF. So in this type we substitute the values, cross multiply this equation and we got the length formula. That length formula is 1 by V minus 1 by U is equal to 1 by F. So in this type we derive the expression for the length formula. Thank you.